Sydney, can you hear me now?
Yes, I can hear you.
Okay. She said yes, right?
Yes.
So the title for this lesson is Isotopes and Average Atomic Mass. So we'll do this in two sections, right? First, we'll quickly review isotopes, even though you've presumably already learned about them. And then we'll go on to average atomic mass. So can anybody tell me what is an isotope? Perfect. It is two atoms. They have the same number of protons, but different number of neutrons. So let's say, for example, that this is a container, right? In this container, you've got some atoms. Maybe a good color. Maybe this one. I'll make them solid just so that they can pop out a little more. Okay. So you have three different kind of circles, right? Think of those as three different isotopes of the same element. Namely H1, H2, and H3. What is H1, H2, and H3? What element am I referring to? I'm referring to hydrogen. This is the simplest element in the periodic table, and it comes in three flavors. All of them are hydrogen. Because they're hydrogen, they have the same physical properties, they have the same chemical properties. Like, for example, what is one physical property of hydrogen that we know? It's a gas, right? H1 is a gas, H2 is a gas, and H3 is also a gas. Just because they have different number of neutrons does not change their physical properties. What is the chemical property of hydrogen? Come on, y'all, learn about this in social studies. There was this big giant blimp that caught on fire. Hydrogen is a highly flammable gas, right? That is the chemical property. All three of these isotopes are equally flammable. Just because H3 has 2 extra neutrons does not make it any more or less flammable. Does that make sense? Isotopes have same chemical and physical properties. The only thing that's different is the number of neutrons, and because of that, their mass. That's it. Okay? Nothing else is different. So, next question here is, Ms. Evans, will you let Frank in? There's someone in the waiting room. Okay, so my next question is about abundance. Have you heard that term before? What does abundant mean? Plentiful. That's a great term. Plentiful. In this particular container, which is the most abundant element? Isotope. The white one. Because that's the most circles you have, right? Are those of the white Which is the least abundant? The green, because you have the least of those. Now, if you were to, without looking, just put your hand in this container and take out one atom, what flavor do you think this is going to be? White, red, or green? The white. Why? Because there's more of it, right? That just makes sense. So that is what abundant means, right? So let's say, for example, let me color code this so that I can continue using the same example. So this is H2, and then this is H3. Okay, next, my atomic mass of hydrogen is 1.008. Where did I get this number from? I got this number from the periodic table. Let's say if you didn't have this diagram, and all you have is H1, H2, and H3, and the average atomic mass, which isotope of hydrogen do you think is the most abundant? Because that is a question, like not this exact question, but a question like this is on your test. Which isotope of hydrogen, given this much information, is the most abundant? Obviously, you will not have a picture next to it. Why H1?
Because it's closer to the
Exactly, because it is closer to the average atomic mass, right? If the atomic mass was 2.008 instead of 1.008, then which isotope would have been the most abundant? The H2. Okay, so all you have to do to figure out which isotope is more abundant is look at the average atomic mass. I'll give you another example, that of, let's say you have the element chlorine. Chlorine comes in two flavors, chlorine 35, chlorine 37. According to the periodic table, the average mass of chlorine is 35.453. Which isotope of chlorine is most abundant? Well, so say chlorine 35, right? Chlorine 35 is the most abundant. How can we be so sure? Because the average mass of chlorine from the periodic table is 35.453. Okay? So it is very easy to tell which isotope is more abundant. You simply look at the average atomic mass. Whichever mass is closest to that average, that's the most abundant. Okay? So now, let us go to the, oh, there it is. Let us go to the next topic, which was finding the average. Now, in everyday life, how do you find average? Right. You add everything up and then divide it by how many you had, right? But here's the problem. You cannot do that in this particular instance. Okay? And the perfect analogy to remember this is to remember how you calculate grades. What are the three categories in your grade book? And because this is a science class, you also have a lab grade. In most like other classes, you only have daily and test. But here you have daily, test, and lab. So the distribution of that is test is 60%. Your labs are 20%. And your daily is 20%. Now let's say a student has these grades. He has 100, 85, 100, 90. Those are his daily. Then for lab grades, he only did one lab and he got an 85 on it. And then for test, he had a 75, a 50, and an 80. These are the grades. How do you calculate the grade of the student based on those weighted averages? But this is like exactly how you calculate your grade.
Test grades.
Uh-huh.
Divide that by 60% and then the same with the other one.
Divide by 60%. What does that mean? How do you divide by a percentage? Because you have the right concept, you're not putting it in the right terms. That's all. Here's what you have to do. You add up all the individual categories and find their average. So 100 plus 85 plus 100 plus 90 is 2, 3. And then this is 5, 205. Right? Then you find the average of the individual categories. So divide this by 4, this by 1, this by 3. So what do we get? 9, 5 point, we'll just say this is 96. It's close. And this is 68. We'll say 68. Okay? So, and then this is obviously 85. Now can you just add and divide? No, because they have different weights, right? So all you have to do is take the average of these and multiply them by the fraction of each category. Not the percentage, but fraction. So if I want to convert 60% to fraction, what do I have to do? 60 over 100, right? In other words, you simply move the decimal 2 places to the left. Just like that song. What song? To the left, to the left. No? Never heard that before?
Are you talking about the Cuban shuffle?
No.
I don't know what you're talking about. Are you talking about Beyonce? Or...
Is that Beyonce? I don't know. Is that Beyonce? That is Beyonce. Yeah. 2 places to the left. I remember that last period. I'm very proud of it. I'm going to repeat that every class period. But hopefully you will remember that. Okay? How many places do you move? 2 to the left. Okay? 2 places to the left. So 60 turns into 0.6. And then 20 each turns into 0.2. Then you multiply them and add them at the end, right? So 96 times 0.6, 85 times 0.2, and 68 times 0.2. And then you simply add them. Say that again. Oh, shoot. Sorry. Good catch. There. And you'll have 3 answers. You add them together, and that's your final answer. Okay? So let us use, this is how you calculate your grade. Let us use the same exact technique to find average atomic mass. Okay? So Si28, Si29, and Si30. These are the three isotopes of silicon, which means they have the same exact physical and chemical properties. Notice how I'm repeating this over and over again. That must mean that it has some weight on tomorrow's test. Please remember that. There is a question, maybe two, over this whole topic, and I'm about to sleep. Excuse me. Thank you. Did you already admit her? Okay. So
Did you ever get that movie thing you watched for you?
what movie?
I think that movie you watched.
No. Oh, yeah, that. No. I think you have to let her in again. Is she in? Yeah, there you go. Dang it, I forgot the percentage. Hold on. Add these two numbers real quick and subtract from 100 the percentages. Add the two percentages together and subtract them from 100.
Point 0483.
Point.
0483.
Okay. So based on this information, which is the most abundant isotope? Silicon 28, right? Which is the least abundant? Silicon 30, because that's the least percentage, right? So that is the least abundant. Now, how do you find the average atomic mass? The exact same steps that we just followed to find your grade. What do you do with the percentage number? You turn it into a fraction. What do you do to the decimal? 2 spots to the left. And then you multiply. So instead of 97.378, you get 'Is that right? Or is that one? Do I need one more zero? There you go. So you will have You'll have 3 answers. You add them together and that's your final answer. The only thing you need to remember is the rules of sig fig. So who can tell me how to multiply and add these numbers correctly?
Wait, what?
How do I multiply and then eventually add these numbers according to the rules of sig fig? Something about the least number of sig figs, right? You have to look at individual multiplications first. So let me change the ink. There we go. So right here, how many sig figs do I have? I have 6 sig figs. And in the number below it, five. The 0 is not significant, right? So you're multiplying 2 numbers. One has 6 sig figs, one has 5 sig figs. Your answer can only have 5. So go ahead and real quick tell me the whole answer that you get on the calculator and then tell you how to round it to have 5 sig figs. Okay, so do 27.9973 times 0.97378. And tell me the whole answer that you get on your calculator. $27 point. So that's clearly way too many sig figs, right? We're only allowed to have 5 in this case. So you start counting from your left. This 2 stays. This 7 stays. So that's 2 sig figs, 3 sig figs, 4 sig figs. Now when you come to the last sig fig, you have to look at what's the number after it. It is less than 5. So it stays the same. So now you're going to get rid of all of these. And this 3 stays the same, right? And so what is your answer? 27.363. Do the same for the other 2. How many sig figs do I have in the top one? 6. How many in the bottom? No. 5. So the 0.02, right?
Yeah, but what about the 0?
I think it.
The 0 is not significant.
The 0 before the 2. Like,
Correct. It's not significant. It is after the decimal, but it is not after the first whole number. These are called trailing zeros. So they're not significant.
I thought it was the decimal that was supposed to be.
Okay, look, if this is the number, right? These zeros, not significant. This 0 is significant.
Is that a 37?
Yeah.
Do you want the answer?
Yes, please.
It's 0.74629.
No, give me only 5 sig figs.
Oh,
0.74.
629.
Okay. And then in the last one, you have 6 sig figs up top, but only 3 sig figs on the bottom. So your answer can only have 3 sig figs. So what is the answer? Zero point?
Oh, wait, no. Never mind. I'm tripping. I ain't getting no money over there.
0.0144.
0.00145 then. That's the number after that is 8, right? Okay, so then all you have to do is add these. And find your answer. So what is the answer? Okay, so what have we done? We took the masses of the individual isotopes, multiplied them by the fraction, and then you add them together. That's all you gotta do. So what is the answer for those three?
28.1237.
Okay, can anyone tell me what is the problem with this answer? Lowest one what? Whenever you're adding or subtracting, you only look at the number of decimals. Okay, so in the first number, how many decimals do I have? I have 3 decimals, right? Here I have, and here I have. You have to go with the lowest, which means only 3. So you start counting from the first decimal. So this 1 stays, this 2 stays. Will the 3 stay? Because the one after that is higher than a 5, right? So this changes to a 4. And so your answer is 28.124. This is how you calculate average atomic mass. What do you have to do? Take the individual masses, multiply them by the fraction, add them up at the end. That's it. Okay? So, any questions? It is fairly straightforward. There are like 2 questions like this on the test tomorrow. But luckily your test is on multiple choice. Okay? So it should be pretty straightforward. There's 20 questions on the test. And the exact same way you did last test. So on your computer, you come into the class, you click here to test, and just go from there. Okay? And for those of you who are remote, please make sure that you log in during your second period class and be sure to join the Zoom link that is on it is not this link, okay? The Zoom link is on the post for the test. You guys have any questions about this? Sydney and Lisette? Are you still here? I can't hear you.
I don't have any questions.
Oh, okay. All right, sounds good. Then I'll see you guys tomorrow.
Okay, are we supposed to be doing the app puzzle now?
Well, you should do your RAM assignment first and then that puzzle, but yes. All right, you want to do third period?
This is third period.
Oh, this is third period, isn't
Yeah.
it? Oh. Well, I guess then you can do sixth. That's crazy. I didn't realize this was third. I thought this was second.
No.
So hungry. And my freaking oatmeal just exploded in the microwave, which is just perfect. Okay, Aaliyah.
here. Archie is here. Harris is here. Kiera is here. Is here. Is here. Right. Yun. And then who were the two in the meeting? I think it was Lisette and Sydney, right? I'll go ahead and mark them distant right now. Oh, she's not in this class. Lisette Sanchez.
She's in.
Oh.